We live on a mote of dust, suspended in a sunbeam, adrift in a cosmic ocean of unimaginable scale. For centuries we've gazed up at the night sky, driven by an insatiable curiosity to understand our place within this grand tapestry. We've mapped stars, charted the course of galaxies, and even glimpsed the dawn of time itself, yet for all our progress, the cosmos holds its cards close. The more we learn, the more we realize how much we don't know. These cosmic enigmas remind us that we are still explorers, still beginners on a journey of discovery. So, tonight, let's venture into that darkness together. The universe is waiting. Let's begin with something you can't see, can't touch, and can't detect with any of our conventional instruments. Yet we're almost certain it's there, and there's a lot of it. I'm talking about dark matter. When we look at galaxies like our own Milky Way, we can measure how fast the stars on the outer edges are spinning. Based on all the visible matter we can account for, those outer stars should be moving much, much slower. In fact, they should be flung off into intergalactic space, like children flying off a merry-go-round that's spinning too fast. But they aren't. They're held in place, orbiting at incredible speeds. Something else, something invisible, must be providing the necessary gravitational glue to hold the galaxy together. This something is what we've dubbed dark matter. It's a ghost, a phantom that passes through us. The numbers are staggering. All the stuff we know and love accounts for only about 5% of the universe. About 27% of the universe is this mysterious dark matter. For every 1 part of normal matter, there are more than 5 parts of this invisible substance. We've built incredibly sensitive detectors deep underground, hoping to catch the faint ping of a WIMP bouncing off a nucleus. So far, silence. The quest to identify dark matter is one of the most urgent pursuits in all of physics. If dark matter is the universe's mysterious glue, our next mystery is its polar opposite. It's a force that's actively pushing everything apart. We call it dark energy, and it is, without a doubt, the single greatest puzzle in all of science. In 1998, 2 separate teams of astronomers were trying to answer the ultimate fate of the universe. They were using distant supernovae to measure the expansion rate of the universe in the distant past. To their utter astonishment, they discovered that the expansion of the universe isn't slowing down at all. It's accelerating, it's speeding up. Something is stepping on the cosmic gas pedal. It's as if you threw a ball into the air and instead of falling back down, it shot upwards into the sky with increasing speed. Dark energy is believed to make up a whopping 68% of the universe. We live in a cosmos overwhelmingly dominated by 2 substances we know almost nothing about. One leading idea is the cosmological constant, a concept Albert Einstein himself proposed and later called his biggest blunder. When quantum mechanics tries to calculate this vacuum energy, the number is 10 to the power of 120 times larger than observed. This has been called the worst theoretical prediction in physics. Imagine you're a radio astronomer, listening to the gentle hiss of the universe. Suddenly, for just a few milliseconds, your telescope detects a burst so powerful it outshines entire galaxies. The first FRB was discovered serendipitously in 2007, hidden in archival data from 2001. At first, many were skeptical. Could it be interference from a microwave oven? Yes, that actually happened with a different signal. The sheer energy involved is honestly mind-boggling. To be detectable from such distances, an FRB must release as much energy in a millisecond as our sun does in 3 days. Could they be magnetars? These neutron stars have magnetic fields trillions of times stronger than Earth's. A starquake or magnetic field reconfiguration could theoretically unleash a colossal burst of energy. Could FRBs be artificial? Perhaps evidence of advanced extraterrestrial technology? While most scientists consider this unlikely, we cannot definitively rule it out. The truth is, we just don't know. On the night of August 15, 1977, Jerry Amen was a volunteer for SETI at Ohio State University's Big Ear radio telescope. For 72 seconds, the Big Ear picked up a strong, narrowband radio signal from Sagittarius. It was tightly focused and powerful, over 30 times louder than deep space background noise. When Jerry Amen reviewed the printout days later, he was so astonished by the signal's profile that he circled it in red ink and wrote a single word in the margin. Wow! The name stuck. It occurred at the hydrogen line frequency, which SETI scientists propose as a logical channel for interstellar communication. Hydrogen is the most abundant element in the universe. They pointed much more powerful telescopes back to that same patch of sky, they listened for years, and they found nothing. Absolute silence. The signal has never been detected again. It was a one-time cosmic whisper that has never been repeated. Was it a deliberate message from another civilization saying, "We are here," a 72-second postcard from the stars? The Fermi paradox, named after physicist Enrico Fermi, who asked a simple but profound question: where is everybody? It's about an absence, a silence. Our galaxy contains an estimated 100 to 400 billion stars. Recent discoveries suggest planets are incredibly common. There are likely trillions of planets in our galaxy alone. The universe is 13.8 billion years old. Our solar system is a newcomer at 4.5 billion. There could have been planets that formed billions of years before Earth, giving life a significant head start. If even a tiny fraction developed intelligent life and interstellar travel, the galaxy should be teeming with civilizations. A single civilization could colonize the entire galaxy in just a few million years, a cosmic blink of an eye. So where are they? Why do we see no evidence of them? When we look up at the night sky, we are met with a profound and unsettling silence. Perhaps we are truly alone, the first and only intelligent life in this galaxy. This is the rare Earth hypothesis, or maybe civilizations inevitably destroy themselves before achieving interstellar travel through war, climate change, or technology misuse. Maybe they're deliberately hiding, observing us like we observe animals in a preserve, the zoo hypothesis. We might be like an ant colony on a superhighway, completely unaware of complex civilization operating on a different plane right next to us. From the invisible scaffolding of dark matter to the silent expanse of the Fermi paradox, we've journeyed to the very edge of human knowledge. These 5 mysteries are the blank spaces on our cosmic map, reminding us we have only begun to explore reality. These puzzles are not cause for despair but a call to action, a grand invitation to the next generation of thinkers and explorers. They are the fuel for our scientific curiosity, the driving force behind every new mission and bold idea. Each mystery holds potential for revolution in our understanding, a paradigm shift that could reshape our technology and philosophy. The quest for answers is one of the noblest things we do. So I leave you with this thought: will we one day shake hands with an extraterrestrial neighbor? Will we finally understand the dark side of the cosmos? I don't have the answers, but the pursuit is what matters. What are your theories? Which mystery fascinates you most? Let me know in the comments below, and as always, keep looking up.